I will be recording our classes from now on, and I'll post that link to the recording right below the class link. Okay, I'm admitting more students here. So what I'm talking about is right here, recording of today's class. That's where I'll post it. So if you need to, for whatever reason, you had technical difficulties, or maybe your sleeping hours are messed up. Anyway, you should still try to make it to class, but should you miss class, there it is. So I've got a lot to cover today. Quickly, I want to tell you, please watch these two videos. It's the quickest way I can get information to you. When you take your quiz, I'm going to go here. There's an email that I sent to you. I really appreciate it if you respond to this email with your quiz submission. So you're going to take readable pics. Please respond to this email because I have 105 of you. So I don't want 105 separate emails in my inbox. I want 105 emails in one email. So please respond to this one. There's some other things in the videos that you need to look at. One especially, give me a moment here, concerning where am I here? Concerning the last problem, if you got a paper copy, you picked up paper copies, I didn't have the X and the Y intercepts put in there. All right, so I am going to get started on going through a practice quiz here. And so you can follow along. If you want to just watch, that's okay. Whatever you want to do. And then tomorrow's the quiz, which I sent to you, or you have a paper copy, either way. And then you're going to take that and send me readable pics. Okay, so problems 1 and 2. These tend to be missed more than they should be. So what you're going to do on problem 1 is you're going to take all of the factors with their powers, and I want you to write them on top of these boxes here. X minus 1 squared, x plus 3, x plus 1 squared, and then 2x plus 3 squared. Just write them left to right on top of the boxes like that. And then basically what you're doing is you have to go back to remembering how a factor works with the x-intercept, because zeros are the x-intercepts. So this is practice with this before you get to a real problem with this. So if it's a factor of x, the 0 is 0. If it's a factor of x minus 1, it's 1. If it's x plus 3, it's negative 3. If it's x plus 1, it's negative 1. If it's 2x plus 3, it's negative 3 over 2. And how do you get that? You set it equal to 0, and you solve it out. Yes, this has to do with factoring. So if negative 3/2 is the factor, denominator times x, opposite of the numerator to write the factor. That's literally what's going on here with these two. And the multiplicity is the power on that factor. So this is a little bit of highlighter. You could maybe just do 1 here, save a little time. So those are the same every time. And the multiplicity has to do with how the graph is cutting through the x-axis, and this is fairly valuable information, okay, when looking at graphs and answering questions, especially on the SAT. They like questions concerning this. Problem 2, what's the leading coefficient? So you can type this great big long beast into Wolfram Alpha. This is one of the apps I'm going to let you use. to get the expanded form. However, that is not necessary. You can actually do the multiplying out. So you're going to start with this common factor, and then it's the coefficients on x raised to the power, the multiplicity. So 1 squared times 1 to the first times 1 squared times 2 squared. So all of that would give you the leading coefficient. Now there's a reason I write the ones in. Separate that a little bit, because they could be other numbers. So you can just do all of this and it gives you -16. That's the simplest way. Or you can type it into Wolfram alpha, it'll expand it out, and the first term would be -16 x to the 9th when it starts it. And so then -16 is the leading coefficient. So whatever you feel most comfortable with in doing that. All right, problem 3. You're going to, first thing to do, take this in, and this time I'll show it, into Wolfram alpha and type expand all of it. And then it will do it and give you the result. And then you're going to write that in the standard form equation line. And you can do this on any of these. And most of them you'll have to do this on. Okay, so that, type it in up here, press enter, it will give this to you. Please don't use the graph to graph. Okay, I don't want you to use Wolfram for anything but that. So you're going to write that in, and then you're ready to answer all of this and do a graph, and I'll show you the meta calculator. That's the site that I want you to use for the graph. All right, so we have a degree of 4 and a leading coefficient of 2. So how do I know that? Well, it's the highest power is the degree, and then the leading coefficient on that. So this is an even positive. So an even positive, out will come this, and 2 positive infinities. Okay, the y-intercept is 0. Now you're ready to do this table. And so basically what you're doing is you're putting all the factors above here with their powers. Okay, and then solving them equal to 0. And then taking the exponent on all of these. Okay, and then we're ready to do the graph. Now what you should do before you do anything else is to actually take a look at the graph, okay, and -2, to see what to expect. And what to expect is that you have a pretty low minimum here, and then it cuts back through at 0 and goes way up, comes down to 3, and it's going to bounce because 3 has a multiplicity of 2. Even multiplicities bounce. And so taking a look at this, I'm going to go way down and then come back, and it's going to come way back up. And then it's going to bounce at 3. The problem is you don't know how far down or how far up. So what you can do is go to the meta calculator site. I really like this. And so put this in and then use your I think actually it would look like this when you first put it in, and then just use these two to zoom out. And then you can see that, you know, this peak is quite a ways up there at 25. And then way down here, this is way down at -34. It's not important for what we're trying to emphasize, but at least you can see it when you sketch it. Let me zoom back in here to where you can like see the x-intercepts normally. So that's how it would come out normally. Then you'd have to just minus out to get those. So sometimes those peaks are way down there and way up there with what you have to do. All right, problem 4. So you're going to take this and expand it. Now I put a line through there, but you really should do it because I think it just helps to see all of this. I'm not going to do it, but I will tell you that your leading term is x to the 5th. And then there's a bunch of stuff in the middle and then 16 on the end. That much I can do mentally. But you probably should go in and expand it out so that you can see. All right, so degree is 5, leading coefficient is 1. That's an odd positive. That means when you look that up, odd positive, you have this situation, negative infinity and positive infinity for the end behaviors. The y-intercept is 16, so it's that number on the end. And then you just want to take the factors with their powers and write them down right above here. That's a 3, excuse me, 3. Okay, so -2, 2, and 1. Multiplicity is 3, 1, and 1. Remember, those are the powers on the factors. And now it's time to sketch. So this is the first time we've had a multiplicity of 3. And way up here at 16. So we have a multiplicity of 3 at -2. So what that means is that at -2, the graph is going to cut through like this. And you should look at the graph again to see that, but it's going to flatten out around 2. And then it's going to come up to 16, and you can look at the graph again to see, you know, does it have a peak and then come back through 16, or does it cut through 16 and have a peak afterwards? You can check it out, but it's very close to 16, the peak. So I'm just going to leave it. And then it's going to cut through 1 and then come back and cut through 2. And that's as good as I'm going to make it. Again, I'm looking for these things right here. Are you getting those, the behavior of the graph through the x-intercepts correct? That's the big thing on this quiz to learn. And then next year, if you continue in your math, you'll learn about the peaks and the turning points, and then where it turns over from being shaped down to being shaped up, so on and so forth. All right, problem 5. What you're going to have to do with this is you're going to have to go into the math portal site, and you're going to type in this, x cubed minus 6x squared plus 12x minus 8, and then hit solve, and it will give you 3 2's. So what that's telling you with the 3 2's is that you have, we'll write this down, x minus 2 3 times. And if there was a common factor, you can tell there's not here. I would tell you with a heads up. Okay, so you have both of those. Degree is 3, leading coefficient is 1, so this is an odd positive again, meaning that we have negative infinity, positive infinity right here, and that this is minus 8, the number added on the end. And then you're ready to build this table into graph again. So this is what we have, 2 and 3. So you can write this like this. So that means at 2, it's going to get, so it's going to come up through -8, then at 2, it's going to cut through flat, and then just continue. because of that multiplicity of 3 means that it gets flat through that. So if we had a multiplicity of 4, the bounce off would be flatter. We're not going to have any multiplicities of 4, but if that were the case, the higher the multiplicity, the more flat its behavior is as it either cuts through or bounces off. Okay, moving on, problem 6. So you're going to start with the x-intercepts here. Down here, so we have -2, 1, and 3. And notice they just cut through, and it's not flat. So these would all be a multiplicity of 1, meaning that we just have the factor to the first power. And you still need to remember that relationship between the zeros and the factors that has not gone away and will not be going away anytime soon. And again, I would tell you if there was a common factor. You can tell there's not because the y-intercept is 6 here. And so if you expand this out, you actually would get a y-intercept of 6 and it would work. But I would tell you if there was, so you can take this into Wolfram, expand it out, the Wolfram alpha site, and it would give you this, minus 2x squared minus 5x plus 6. And then you can fill the rest of this in, and it has to make sense with the graph. So odd positive says this for the end behaviors when you look it up, and the y-intercept says 6, and you have 6 for the y-intercept. It all has to fit. If it doesn't all fit, you did something wrong. Okay, so that's the main part of the quiz. And then you come upon, I got 3 minutes. Can I do it? I gotta work fast. You come upon 7 and 8, and these are gonna be optional. Okay, so with time constraints, but I really strongly recommend that you do these because it's an easy A on a quiz, we'll say it that way. So this first problem is substitute in 2 for x, 5 for y. The f of x is y. And then you can figure out b. So the emphasis with the spiral in trimester 2 is to give you a taste of how you would see this on an SAT. So you're going to simplify all of this, go through, add the 12 and 15, subtract the 27 over, and then divide both sides by 2. Pretty easy work in the end, but what you need to know is you need to simplify. Okay, 2 minutes. Can I get this done? So here, you need to think about, so this is the FOIL product, but you got to figure out A and B. And so 7 and 1, it has to be. And it doesn't matter what way you write it. You could write it that way or you could write it this way. It's going to be the same thing. So when you take this FOIL product, oops. So first 2 outer, inner, last. When you add the 7 and the 1, that gives you 8. And so that's what they want. It's really asking for the B value in that. All right, I just made it. So follow the directions about submitting the quiz. If you didn't pick up the paper copies, you can just do the quiz on regular paper, but your writing needs to be readable. And when you submit things, it needs to be readable. So you'll always get one of these emails sent to you every time there's a quiz, and you just respond to that. And generally, as soon as I get them, is pretty much as soon as I grade them. So just ask if you have questions. Feel free anytime to ask. All right, I'm going to stop recording, and we will see all of you Thursday.